Hi students, in this video we are going to see the image formation in spherical mirrors. The first one is if the object is behind the center, this is our object. Then the image formed is between the center of focus. It is a small inverted and a real image. This is our image. In order an image to be formed, we need two special rays. You see here one is parallel to the principal axis, reflected passing through the focus, and the other one is to the vertex, making the same angle with the principal axis. It is reflected like this. So at the intersection point of these two reflected rays, our image is formed. You see this is a small inverted and a real image. Why real? Because it is formed by the intersection of real reflected rays. The second one, if the object is at center, again this is our object, then the image formed is also at the center. This is our image with the same size, inverted, and a real image. We get a little bit closer. Now our object is between center and the focus. This is our object. Then the image formed is behind the center. You see here. It is a big, inverted, and a real object. If the object is at focus, then all the rays coming from the object will be parallel to each other. So the parallel rays don't intersect. We assume that they intersect at infinity, so the image is at infinity, or you may say there is no image. If the object is between the focus and the mirror, then the image formed is behind the mirror. It is a big, the only upright and virtual image. Now let's look at here. One parallel to the principal axis, reflected passing through the focus, and the other one to the vertex, making the same angle with the principal axis. So these two rays cannot intersect. So we take the extension of these rays, and the image is formed at by the intersection of the extension of the reflected rays. It is behind the mirror, that's why it is virtual, and it is a big and upright image. What is important here? The only upright and virtual image is formed when the object is between focus and the mirror. The others are all inverted and real images. So we can generalize that when the object gets closest to the focus, the height of the image increases. If the object is behind the focus, then the image formed is inverted and real. If the object is between the mirror and the focus, then the image formed is upright and virtual. Now let's make a review. In a concave mirror, we have focus and center. If the object is behind the center, then the image formed is between focus and center, small, real, and inverted image. If the object is at center, then the image formed is at center with the same height, inverted, and a real image. If the object is between focus and center, then the image is behind center. It is a big, inverted, and a real image. If the object is at focus, then the image is at infinity. If the object is between focus and the mirror, then the image formed is behind the mirror, a big, virtual, and upright image. In convex mirror, we have only one type of image. object at any point, the image formed is always behind the mirror. It is a small, upright, and a virtual image. Here you see there is a parallel ray. It is reflected as its extension is passing from the focus and one to the vortex. So you see that these two reflected rays cannot intersect. So their extension intersect, and here our image is formed. When you get closer to the mirror, this ray doesn't change, but the one coming to the vortex will be like this. So the intersection point will be here. So when you get closer to the mirror, the image also gets closer to the mirror and gets bigger. We have some special cases you can use in the problem solutions. In concave mirrors, if the distance of object to the mirror is 3f, then the distance of image to the mirror will be equal to 3f over 2. As in this example, this is your object, the distance is 3f, so the image formed will be at 3f over 2. If the object is at 3f over 2, let's say if the object is here, then the image will be formed at 3f. If the object is f over 2 away from the mirror, so you see it is between the mirror and the focus, then we've got a virtual image with a distance of f. Why it is minus f? The minus here means that it is back of the mirror. In convex, there is only one special case. If the distance of object to the mirror is f, then the distance of image to the mirror is equal to f over 2. Here we have another relation. The distance of object to the mirror over the distance of image to the mirror is equal to the height of object to the height of image. So these ratios are equal. So here we can say that if the object has a height of h, then the image will have a height of h over 2. Here in the second one, if the object has a height of h, then the image will have a height of 2h because the distance doubles. In the third one, if the object has a height of h, then the image will have a height of 2h. If the object has a height of h, then the image will have a height of h over 2.